we are seeing species change.
Well, we're seeing a lot of species disappear, and we're seeing other species adapt. Because that's
well, yeah, you got to pull yourself up by your DNA bootstraps.
There is no waste in nature. The system is productive. There's productivity in the system, and something is going to utilize that productivity. For instance, in the Bering Sea, it's one of the most productive continental shelves in the world. Well, that productivity is going to go somewhere. If pollock aren't there to eat it, something else will be. And measuring and quantifying those changes are our job to be able to sort of predict what the ocean is going to look like down the road.
And the impact on Alaska is going to be those things that are going to benefit. Are they going to be things that that we find valuable to eat or to sell? And
And I don't remember this because I wasn't around, but at one point, southern Alaska was known as a shrimping industry, right? So there were massive shrimp catches in southern Alaska, and then
there was shrimp and catch back then.
Right. Then there was a big regime shift. The climate shifted, and the system became much more favorable to bottom-feeding fish, and that's where the halibut and the more of the pelagic water column fish showed up. So you don't catch shrimp in southern Alaska anymore.
There were also a lot of people catching them all day, every day.
Well, I think that had less to do with the removal of them from the system than there was a clear shift in the ecosystem. The climate shifted such that shrimp were no longer the dominant species in those places, but the system did not become unproductive.
Does it do the same thing that, like the fox and the rabbits sort of, and we've got more links here than we know what to do with in Anchorage right now because the rabbit population's up. I mean, do the oceans work the same way, Jeff, where they sort of have this, cyclical thing going on, or do they pretty much just sort of settle down and do their deal for the most part?
Marine ecosystems in general are tremendously complicated. They're much more complicated than a simple relationship between lynx and rabbits. So it makes it really hard to anticipate what changes are going to come down the pike from something like ocean acidification. But I would just go back to what I brought up earlier, though, that the last time this happened in the geological record, when there was a really fast change, and that's what's creating the stress, is how quickly the ocean is changing, so that a lot of species just don't have time to adapt. And they're going to face a very different, and most of the time unfavorable changes that they're going to find it difficult to cope with. And that's going to lead to overall general simplification of marine food webs. On average. So yeah, there'll be some winners and losers, but there's probably going to be a lot more losers than winners.
Say that again. There's going to be more what than who?
Losers than winners.
Okay, so then that's maybe a good reason to figure this out, and if there's something we can do, we should do it. Yeah. I mean, do you think it's arrogant that when people say, man can't have this much cost? Driving around in my car, my snow machine with the great big muffler, no, I'm not compensating sort of model. When people are doing that and they're like, it's totally arrogant for us to think that we could have that much effect on the climate, because I mean, a volcano goes off and good Lord, what all's coming out of that thing?
We figured out the basic science behind ocean acidification, I don't know, in the early 1800s or so. It's the same deal when you make carbonated water. You put carbon dioxide in the air above some water and it dissolves and it makes it more acidic. You put carbon dioxide in the Earth's atmosphere and it dissolves and it makes the ocean more acidic. This isn't some fancy climate model or anything. It's real simple.
Like you could do this one with Legos at home.
You can do this at home.
Right.
And I do an experiment. I teach an undergraduate course at UAF, and I take and I give the students a bottle of seawater, and I give them a straw. I hand out straws, and then we pass the seawater around, and they all take turns blowing bubbles into the seawater, and we measure the pH before they start blowing bubbles. And as it passes around the room to 25 or 30 kids, we can drop the pH by 4 or 5 pH units by just them blowing bubbles into this jar of seawater. And what they're doing is they're putting CO2 in the water in a very confined system.
Have you checked it for THC?
No.
It is Fairbanks. It is Fairbanks.
But it is a very straightforward way. So it's a very straightforward way to demonstrate exactly what Jeff is talking about. You put more CO2 in water, and it becomes more acidic.
Okay, so how is anybody out there saying, nope, it's not real, it's just not? I mean, were their parents cousins or something? I mean, seriously, if you can do it with students, a couple of straws, and a bottle of seawater. Really? How hard is, how did the deniers do this? It's like, no, gravity, it's not real. I'm staying here because I want to. No.
Well, I've certainly found that there are less naysayers with ocean acidification than there are with other climate change scenarios, because it is, you can demonstrate ocean acidification very clearly and very robustly. There isn't really an argument to be made against
a
ocean
snowstorm
acidification.
in January, south of the Mason-Dixon line, that people are like, there's no global warming. Okay, fine, but ocean acidification, really, you're not getting any argument.
It's very hard to come up with a plausible counter stance against ocean acidification.
Is it because people just aren't aware of it?
I think that's the biggest
ocean
problem.
Acidification, I went to a rally in Homer, the SOS rally, all these wonderful boats went out, Cook Inlet Keeper organized this big thing, and it was really amazing, all these boats spelling out SOS, and there was a big spotlight from a helicopter. Really just kind of a fun day to be on the water in Homer, frankly, but it was to get this picture with over 100 boats participating to try to get people aware of it. And there were people in Homer, Alaska who were like, what is it about? Like, they wanted to, but they hadn't even heard the term ocean
that's where we haven't done a
acidification.
very good job of scientists, and that's what we need to start doing, is going out and doing that community awareness as much as we possibly can.
There's got to be a sexier, more catchy thing than ocean acidification. It just sounds like, you dumped a battery in the bay, which has been done. There's that really actually scares the crap out of people. Like death panels for water.
Well, we also have to be very careful as scientists that we're not fear mongering, because that's the danger, is that we don't want to cause hysteria, we don't want to cause panic. We just want to make people aware that this is an environmental challenge that we're going to face, and in Alaska, where a big chunk of the economy, particularly in southern Alaska, depends on these industries. And so it does need to be an awareness, and it is something we need to work
Well, I
harder
get
at.
that as scientists, but at some point, there's got to be a place where scientists start looking at it and go, wow, this kind of scares the crap out of me. I'm not asking you to say that, but I'm just thinking that were I a scientist and you're looking at it, well, maybe you can address this, Jeff.
I'd be happy to.
Where you get to a point where you can't not hit an alarm. It's like, well, yes, there's a fire. I'm the fire assessor. And then at some point you're like, wow, that fire's getting pretty big. And at some point you go, okay, fine, I'm pulling the alarm.
Well, part of the reason that this story isn't as widely known as you would hope is because it only has really recently been widely appreciated, even within the scientific community, that really key papers started appearing around 2004. And I was working at NOAA at that time, and I read those papers, and that's what caused me to start getting interested in getting an ocean acidification program going in the Alaska Fisheries Science Center. And I became frustrated with how fast the government was responding to that, and that's a big reason why I left that position, and I have an advocacy position now.
Was that during the Bush administration?
Right near the end of it, yeah.
Yeah. Well, the rapture isn't an environmental policy.
Yes.
Although it was at that point. I have it.
But
death panels for pteropods.
But it had less to do.
That's the scare thing.
It had less to do with Bush policy or any government policy than it did with the scientific community not recognizing a problem, and because we were talking about at the time and even before that ways to pump CO2 out of the atmosphere into the ocean. We thought of the ocean
right,
as
like
this,
we'll clean our air
by
putting
putting
it in our
the ocean,
water.
and that was a real. I have an engineering degree, and when I was coming through my engineering degree, that was a real issue about how can we engineer a solution to pump carbon out of the atmosphere and into the ocean, because it's this great long-term storage reservoir.
The ocean would just take care of it.
Right, and then we realized, thanks to the pioneering work by people like Richard Feely at NOAA and others around the world, we suddenly stopped and said, wait, well, what are the consequences of actually adding this CO2 to the water? And it was striking when I think we first realized, when some of the first papers started coming out. I remember, I think it was 2003 or 2004, going to a meeting where some of these first presentations were made, and the rooms fell silent, because it was one of those moments where it was like, how did we miss this?
Right, where's the
but we just didn't have, we lacked the imagination.
This mantra of the solution to pollution is dilution, but it's got to go somewhere, and it has, and obviously those cute little pteropods are suffering. I'm Shannyn Moore. We have a great panel. We're going to come back with your questions right after this break.